So we are in chapter 1, introduction. In this chapter, we're going to have discussion on number of sections. First, we'll be looking at research map, then followed by the subject of threats to conclusion validity, then statistical power, and improved conclusion of the subject. So in the previous book, Research from the Start to the End, we have gone through all the technical and practical steps that you need in order to introduce such fine data set. We didn't, of course, discuss any of the technical analysis that need to be done on the data set because it is the main subject of this book. However, before I wanted to jump point 1 and point 2 and etc. until point M. These are the points that represent a summary of the behavior of that population. Now, we want to consider what we can do. We calculate something called the effect size of each one of those variables. In other words, I would calculate how much percentage actually each variable individually is contributing to the inject the null hypothesis. Now, this component is known as the statistical significance. So to recap one more time, the first statistical significance we have explored considering the size of the sample, and the second one considering the confidence interval. Then we have come to understand the effect size, which is addressing the first issue of threat to our conclusion validity, and the last one is considering the statistical significance, the actual details of analysis and the steps and the tools that we use for such purpose. Now, before we start actually exploring the guide map on the idea of analysis, we will have a quick review on just some kind of guidelines also to improve your conclusion validity. That means the number of variables according to our research, either induction or deduction, that those number of variables will help me to find an answer to my research question. And as a matter of the fact, outcome of this space of variable, it is going on with this data set. And as a result, outcome of this graphical and table presentation of summary, you are able to finally. Now, basically, logging of the data doesn't require any technical knowledge, but rather it's a kind of organization mechanism while you are building up your research. In any research project, you may have data will be coming from a number of different sources. Software can control that by summary of the data. Let's say you have entered age as 606, or maybe you set number 7 when you expect the value to be between 1 and 5. So 7 isn't a valid value. These are very important when you transform the data. Now, all these steps and actually just outlines from academic perspective. Later on, we will be doing this in a practical way. I will see you then. But imagine when this X1 is from a research that is focusing on a clinical research is different when X1 focusing on a machine production quality. So exploration on the example of a survey data set and make all the preparation steps as we have explored in the first pillar of data analysis. 6 statements and the scale seems to be from 1 to 5. And of course, if the subject have come to score each one of those 6 statements as 1, 1, 1, you will get lower score of 6 as a total. Otherwise, if you score all of them as 5, then you've got 30. But the most important part, what does the name of this variable indicating? That's why the codebook will help me to figure out what does that exactly mean. So if I head back to my codebook, you could see I have defined every variable name with the full details of subject that we measure this variable which had possible outcome. Now, this kind of analysis, because it indicates only one vector in particular, we call it a univariate analysis. I have possible of green and I know that I have possible of red color. And on the y-axis, state down numbers. It could be in 100 in table format or graph format. Sometimes you might end up by creating more customized kind of a graph. One more important thing I wanted to share with you, any number we calculate on the entire population, we call it a parameter. Any number we calculate on a sample, we call it statistics. So in this case, if happened that my mean is drawn from a sample, it is a statistics mean. If disadvantage I see from a computational power perspective is the use of multiplication instead of summation. But still, the use of geometric mean calculations are quite beneficial, especially in the last measure of central tendency, and that is the proportion. Let's go ahead and have visual presentation on that. As proportion is telling me that A is equal to 3 over the 10. Proportion of B, 4 over the 10. Proportion of C is 3 over 10. The same concept is applied if my x... Welcome back. So we are in Chapter 3, Descriptive Analysis, on the section of dispersion. In this section, we're going to discuss the third important toolkit that you need for your general analysis on a vector variable. We have looked at the first tool of analysis, and that's to understand that. And the second thing you might want to find out also, how far are they from each other? The study of dispersion help us actually to find an answer. And to capture or to answer these two different kind of question, either in terms of the central point, to discuss the variance and standard deviation. Now, capturing one, it's easy to capture the other. The actual meaning of standard deviation is just the square root of the variance. So let's go ahead and have visual presentation on the actual meaning of variance. Sigma square, if this is a population, or my S square, if this is my sample. By taking just the square root of this, this is my actual standard deviation. And what does that mean? So every value I'm going to take, it will be deviated by 2.5. But there's one comeback. So we continue our investigation on the first kind of analysis we're going to happen, x1 and x2, when they are on the zone of being, both of them are discrete. Imagine I've got two variables expressed in the form of a gender, and this is a type of anything you can think about it. Now the gender has two possible outcomes, and for the G, 1, 2, 3 possible outcome for the T. So I need to create possible outcome for something called GT together. You need to multiply 1 times 1 is equal to 1, 1 times 2 is 2, 1 times 3. So we're in Chapter 3, Descriptive Analysis, in the last section of multivariate descriptive analysis. In multivariate descriptive analysis, I consider it as a test for you to see whether you have captured the story from the beginning. So we've started with the explanatory data analysis in the form of univariate analysis. We moved on the bivariate, and that when we had to in the world of multivariate. So I hope now the world of multivariate to you is clear. Chapter 4, Inferential Analysis. In this chapter, we're going to cover a few sections. First, a quick introduction on the meaning of inferential analysis, then estimating parameters, and finally hypothesis testing. The point you captured are actually very close to the real population characteristic in here. Inferential analysis helped me to do that. And to do that, inferential analysis utilize the power of two important actually tools, point estimate and then hypothesis testing. Basically, the point estimate is trying to give you a guideline. Those points, they are really quite a good representative of the real population characteristics or points. And in the hypothesis testing, it's related to the summary. Test whether what you have reached out to can be accepted or maybe can be rejected, in other words. So these are the numbers that contribute to this calculation, which is actually the confidence, the variance, and the sample number. Now, look at the variance. This time, we're going to use something called the chi-square table. It's a standard table just like T, but usually it uses. So we're in Chapter 4, Inferential Statistics, on the discussion of hypothesis testing. Now, we're going to discuss a number of factors that help you to select the right test for your analysis. So far, we have come to, it might be intimidating, but trust me, it took me really quite a long time to compose this in just one table. I'm going to follow the exact logic I have constructed. First of all, how many sample I have. So I might have one sample, two sample, or more than 2 samples.
Hi, welcome back. So we're in Chapter 5, Statistical Software. In this chapter, we'll be looking at a quick introduction on the meaning of statistical software, and then we'll be looking at number of those available statistical softwares. And finally, of course, we'll be looking at lab implementation using one of those available open source software. Let's look at some of those available statistical software. Software can be categorized in the form of open source, public domain, freeware, and proprietary. Now, open source are available software that you can use them, but there are some regulation perhaps you need to check out of Jamovie. Now, basically, once you visit jamovie.org, you will encounter with the couple of options, either to use Jamovie Cloud or Jamovie Desktop. Usually, I prefer to use the desktop by installing the tool on my machine when we start in a while. But I want to say that the only maybe downfall of Jamovie is handling missing values. I didn't see convenient of doing so. If you have a data set with missing values, perhaps it's not the best idea to bring data set to Jamovie with a missing value. Try to handle them, because Jamovie doesn't really offer much of convenience on handling missing data on all over scale. So you have to quite do it manually. Say, for example, I decided to replace the missing value with the mean of a continuous. The size of the engine had quite a bit, not a clear, it's a constant. The mile per gallon was increasing over the time when the engine size was. But once the engine size from, like, say, above 100 started to change, when you put the engine size, the mile per gallon one was fit to do the ANOVA. It was the actual mile per gallon. But let me show you the test of one-way ANOVA again, the Kroskal Wallace. Now, since we have violated the assumption, let me bring you to the map. The Kroskal Wallace, if you remember, it is to test. Hi, welcome back. So we are to discuss the second data set, which comes by default once you install a Jamovie desktop application. The data set is called the bugs data set. Let me explore about the data before we explore the analysis. It was the most frequent one. Next thing, maybe you want to look at the plot. So on the first variable, the low discussed law of Freiden seems to be, to me, of course, not completely normally distributed. Now, if you look at the second variable, wow, that is obvious that the distribution is completely skewed, where you could see the people towards a higher scoring feeling of low discussed significant. This was the comparison across different independent groups. But how about the subject itself? Like this guy, she was a female from North America. She has advanced education, and she voted for feeling low discussed, low frightened 10. And then again, hi, welcome back. So we're in Chapter 6, Lab Section 3. In this chapter, we're going to carry on what we have left over from the first book, Research from the Start to the End. In the first book, we have discussed 2 lab sections, and that is Lab Section 1 and then Lab Section 2. So if you have already enrolled in the first book material, you must be quite a bit familiar with the problem that we are about to do analysis for. In the first lab, established all the academic knowledge on research, from design to framework to structure. And then in the second lab, we actually prepared data by measuring the values on the subject or the research using the instrument that we have already built. So by the end actually of lab number 2, we are able to see the full image, or the complete image. Already completed the first book, Research from the Start to the End. You might find different in the way I formed the null hypothesis against the alternative hypothesis. Previously, I was saying that whatever claim that we have, once it goes to hypothesis, I assume this hypothesis to be already a null hypothesis. But that was from research perspective. It was just like to deliver the link between a claim and hypothesis. But since now we have accomplished all the analysis steps, we must be quite a bit more sensitive towards accomplish. Now, in the next step, we shall be looking at the EDA, or explanatory data analysis, that involve actually the last step of pillar 1, where we prepare the data and everything. And now the focus of pillar 2, where we're going to do the univariate, the bivariate, the multivariate analysis. So we're going to basically look at the organizing, cleaning, the missing everything from pillar 1, and then we create the descriptive model as a pillar 2. And finally, once we come up with a result and inferential something, and we say something about what we have essential data set as we have discussed earlier. And those are the variables. For example, you got the gender, the age, the education, pre-training before or not. These are the demographic variable. And then on the survey standard, I've left already the essential data set has been collected on all the affecting variables that we know so far. And then we're going to calculate the score, prepare them. Now, before that, I want to tell you that preparation for the data set is more productive in a way. So I hope the reverse mechanisms are quite clear to you. Now, at the end, after I finish, I want to calculate the total score for anxiety. I'm going to add the variable. I'm going to this time say on a computed variable, insert. He's asking me, okay, what is the name? I will say, for example, this is the anxiety score of anxiety. I think that is asking me here, offering me number of functions, right? Math functions, you've got statistical function, text function, etc. What I'm interested in actually analysis in a univariate style. In terms of the age, we couldn't really figure out, although the reading was quite intuitive if I want to look at the average medians of the people or the mean as well. In terms of their age, the people who dropped out, they were at age of 36 in average median in the continuous 40 in terms of the people who continued. Aptitude, nothing to tell, absolutely not intuitive. Plan, not really, but it can be considered, but not really strongly good. Expectation as well, just like plan. Excitement, well, kinda, but not completely strong. Discussion or the lab work for our next book, prediction from the start to the end. Now, what we have left is to review the final roadmap of research and analysis all together. In this final chapter, I'm going to recap all the effort and the work from theoretical and practical aspect that we have accomplished so far in both books, because the ideas start all and revolve around the words of research. And the idea of research was actually a kind of a data set where we have number of subjects, right? As a sample, I measured on them the x1, x2, all these space of variables. And once we have this has been done, we move to the stage where we wanted to do some kind of a preparation by cleaning, by handling missing values, checking compatibility, reliability, etc. This is my final structured data set. We move to the second pillar by creating the descriptive model. It gives me the summary. It gives me the conclusion. It gives me the answers. And this is the kind of the knowledge that you might, by creating or model that problem, that can help me next time to predict behavior of any new element might come revolve around the environment that we investigated the problem. In order to put them in such way, I need a third step, and that is to understand prediction from the start to the end. That's exactly where we are heading next. Any question or inquiry that you might need to discuss with me, I would be more than happy to answer back. For now, it has been a pleasure to share with you the knowledge that I have, and I will be happy to hear that knowledge have contributed to your endeavor somewhere along the line. You all stay well, and thank you very much.